Hi, my name is Dr. Gerard Lennon, Professor of Civil and Environmental Engineering at Lehigh University. Today, we're going to do a demonstration. This is a type of soda can that you might find in your refrigerator. The brand type doesn't matter. If you try to balance an empty can, the empty can falls over. If you also try to balance a full can, it also falls over. But if I pour out a certain amount of fluid, will I be able to balance it? Let's see. So I'm going to pour a certain amount of fluid out of the soda can. At the end, we'll be able to measure how much is out of the can. And if I try to balance it, you'll see that the can now does balance. This is an experiment that you can try at home. Most people will just be curious about what just happened. Engineers ought to be more than just curious. They should do some research to find out about and be able to explain the phenomenon. What I'd like you to do is to tell me a good name for the experiment, the major principle involved, a meaningful dependent variable, the major independent variable, draw a sketch of what's going on, and finally, draw a sketch of the variation of the dependent variable versus the independent one. You might need a hint to do this, especially for the last item. Here's a blank experiment assignment that I'm showing on the screen that I use in my junior year fluid mechanics class. And I asked them to fill it out during our first class. So, I teach a course in fluid mechanics, and I have the answer to this question. If you'd like to do research on your own without the hints, please do so. But if you would like the hint, you can contact me to get a little hint, a big hint, or the complete solution. Okay, so here's a close-up. If you examine one of these cans, you'll find it has 355 milliliters. So how much fluid did I pour out? If you take and read the Nalgene bottle level, right now the Nalgene bottle is reading about 230 milliliters. You can read this more accurately on the video. What happens if I pour out a little bit more fluid? So in this case, what I'm going to do is pour out a certain amount of fluid, which you can read off the screen to see how much I've poured out. And you'll see that it still balances. Right now I'm reading about 280 milliliters I've poured out, and you'll see it's just barely able to balance. And if we pour a little bit more out, the can no longer will balance. So if you're a Star Trek fan, you know that transparent aluminum has not been made yet. So we can't see what's going on inside the can. So as a substitute, what we did on a 3D printer, we made a can, and of course it's not an exact replica of the aluminum can because the walls had to be thicker because they failed, and also it doesn't have the same density. Yet it has great value showing you what's going on inside of the can. So we used a 3D printer to make a replica of our aluminum can. What we have here is when we tried to use the same wall thickness of the aluminum can, it failed, double it failed, and we went to 3 times the thickness of the aluminum can in order to make a plastic replica of this on a 3D printer.